Hi everyone, I am Nikhil Kumar Mudesia, along with my teammates Prince Nana and Sunal Pandit are going to present our final year project, and our supervisor is Miss Monica Gaur, and project ID is 10, and our project title is Brain Stroke Prediction System using machine learning. So here is our introduction part. What is stroke? A stroke occurs when the blood supply to a part of the brain is interrupted or reduced, preventing brain tissues from getting oxygen and nutrients. These can be cause brain cells to die within minutes. So, what types of stroke? So, there is a minimum two types or three types of stroke. Ischemic stroke, this can be caused by blockage in artery, and hemorrhagic stroke caused by the blood vessels ruptures leading to a bleeding in our around the brain, often due to hypertension or aneurysms. And third one is transient ischemic attack, which is known as TIA, a temporary blockage often called a mini stroke. This is a warning sign of future major stroke. uh, there is a major impact on public health, like 15 million people suffer stroke annually. WHO 6 million die, 5 million live with long-term disabilities, and stroke is the second leading cause of death worldwide. So there is a common symptoms of a stroke, like sudden weakness in the face or limbs, confusion or trouble speaking, and vision problems, and also loss of balance and coordinations. There is a key risk factors like modifiable. In modifiable, there is a high blood pressure, diabetes, obesity, smoking, alcohol, sedentary lifestyle, and in non-modifiable, there is a age, gender, family history, genetics, and comorbidities. There is a heart disease and artery fibrillation. So here is a literature survey part, in which there is a some author who have worked on that to improve the accuracy, and with different algorithm for the prediction of brain stroke. So like Ahmed et al. In 2019 used random forest with fragment data to predict stroke risk with 91% accuracy, and Usama, Mahajan Sachdeva, and Asan Atel, which is used logistic regressions, SBM, RBF, and employee decision tree with Pernin and grinding index for stroke prediction. And also Said et al., which is uses ANN model using MLP architecture with pre-LAU and drop out layers. In Zhang et al. In 2022 combined CNN with clinical and MRI data for hybrid stroke prediction, which is achieved by 95% accuracy, and used grad CM for model transparency. And our uh, other author Patel and Rana in 2021 used naive base for fast low resources stroke screening with 85% accuracy, and Kumar and Sinha in 2023 developed a Canaan model with 90% accuracy on structured health data. So our other uh, part is proposed work. So in proposed work, there is a problem statement which is used to make the prediction, in which we have take take the topic and problem statement on that, like current stroke detection method are slow, expensive, and often miss early intervention opportunities. A machine learning based system can provide fast, accurate, and cost effective stroke risk prediction to assist in timely medical decisions. So we are here is a proposed solution: develop a machine learning based model to predict stroke risk from patient health data, and use a structured data set with clinical and lifestyle features. And in our we have used 5000 dataset to train our machine learning model to predict and in a better accuracy. And we have apply pre-processing, handle missing data, encode category, normalize value, balance with SMOTE, and train multiple ML algorithms like random forest, SBM logistic regression, in which random forest algorithm which has a high accuracy to predict the brain stroke, and we predict the output like stroke yes or no, which is user friendly for interpretation. uh, okay.
Hello, myself Prince Rana, and today I am going to run my project on the topic brain stroke prediction system using ML. So first of all, open the terminal. After opening the terminal, enter here python app.py and press enter. This will launch our project. This is the front page of our project. So you have to fill all these credentials and then press the submit button. First of all, you have to enter the gender of the patient. If the gender of the patient is male, then enter 1 or enter 0. I am entering here 0. Age of the patient you can enter here 26. I am entering. Hypertension you can enter 1 or 0. Heart disease 1 for yes and 0 for no. I am entering 1 here. Ever married, if he is married then enter 1 and 0 if he is no married. Work type 0 for government job, 1 for never worked, and so on. I am entering here 1. Residence type, if he is living in urban areas then enter 1, or if he is living in rural then enter 0. I am entering 0 here. Here you have to enter the glucose level. I am entering here 150. BMI you can easily calculate using the formula. I am entering here 22.5. Smoking status 0 for unknown, 1 for formerly smoked, 2 for never smoked, and 3 for smokes. I am entering here 0 suppose. And after filling all these credentials you have to press the submit button. This will take some time, and here is the output of the project. You have been diagnosed with no stroke risk. Congratulations. So this is the output of our project. Thank you.
So here is our implementation and testing part, in which we have used six steps to implement the brain stroke prediction system. The first step is data collection. In data collection, we have utilized the Kaggle stroke prediction dataset containing medical and lifestyle features, which has some key attributes, which has age, gender, hypertension, heart disease, BMI, smoking status, work type, and residence type. In second step, we have used pre-processing, in which handle missing values like BMI, encode categorical variables like gender and work type, normalize numerical features to improve model performance, and apply SMOT like synthetic minority oversampling technique to balance stroke versus non-stroke cases. In third step, we have used feature selection, in which we have identified the most significant predictors like age, hypertension, glucose levels, and using this technique like correlation analysis and model-based importance, random forest feature ranking. In through a random forest feature, it will provide better accuracy for our brain stroke prediction system. So fourth stage is model building. In model building, implement multiple machine learning algorithms like logistic regression, random forest, and decision tree. And fifth one is model evaluation. Using model evaluation metrics such as accuracy, precision, recall, F1 score, and ROC, AUC. Compare these models based on performance and generalizability. And sixth one is output prediction. Display final output as a stroke risk or no, and best performing model selected for deployment or further optimization. So here is a result part. We have used random forest for better achieved accuracy of 92% with excellent performance across all metrics. And support vector machine, we have reached accuracy of 89% using the RBF kernel. And decision tree, which has accuracy 87% with strong interpretability. Visualization help identify key stroke risk path. Logistic regression accuracy with 85% and Navy Ways with 85% fast model suitable for low resource setting, which has performed better for on non-stroke classification. And here is a key nearest neighbors algorithm, which has a 90% accuracy, which is worked well with balanced dataset after normalization. And other XGBoost algorithm is highest performing with 96% accuracy, with strong generalization with feature of insight via SHAP. And last one is ensemble model, which is voting classifier, which is used to combine RB, RF, GB and logistic regression for 97% accuracy, which is best F1 score and lowest false negative. These are the chart for comparison of all algorithm. So here is our conclusion part, in which we have summarized all the methods and algorithms to identify a better result and predict the better way with better accuracy. With machine learning models can accurately predict the risk of brain stroke using clinical and lifestyle data. Random forest and XGBoost model deliver the highest accuracy, demonstrating strong potential for real world use. Key predictive features like age, hypertension, average glucose level and BMI. These are the uh, features that we have used in our data to train our model. And this project demonstrates how data-driven solution can improve preventive healthcare and save lives. This is highly scalable and adaptable and suitable for integration into hospitals and mobile health platforms. Thank you.